All right, so we talked about acne, right? That basically around puberty especially, but this could be in anybody, that increased androgen production leads to stimulation of sebaceous glands such that they overproduce, they oversecrete this lipid, fatty, waxy substance, right? And that one can clear it off by cleaning their face, but the androgens are continued to be produced, which means that increased sebum is still produced. So how do we get rid of it? Well, antibiotics, so let's call this treatments, are sometimes prescribed, but they're not going to treat the disorder. Instead, what they do is they kill bacteria that feed on the sebum. Okay, so imagine that you're putting a food source right up to the surface of the skin for bacteria. These antibiotics kill off the bacteria, but again, antibiotics aren't specific. They kill good bacteria in your gut as well as negative bacteria that might promote infection on your skin. So antibiotics are often prescribed in severe acne to reduce bacterial infections if it exists. Right? Something called orthotricycline. Orthotricycline is a birth control medication. And its mechanism of action is similar to how it works in prevention of pregnancy. What it does is it raises the level of pregnancy. It raises the level of estrogens. I'm trying to write and talk at the same time. And what a raised level of estrogen does is it counteracts what androgens are doing. All right, so if we know that these androgens are stimulating sebaceous glands, the orthotricycline is going to increase estrogen and prevent the androgenic effects, right? The problem here is that because we're playing with estrogen levels, there are multiple downstream effects, including effects in how women ovulate. The last one is something called iso. I'm going to spell this right. ISOTRETINOIN. Isotretinoin. Isotretinoin induces apoptosis. SIS. Induces apoptosis. Okay. What apoptosis means is that these cells basically commit suicide. The cells die off when they're exposed to this drug, right? Programmed cell death. This drug is a potent drug, and so people who take it often have other skin effects, right? So maybe the lips dry out and the skin starts to flake. Because again, this drug is non-specific to only the cells that are producing sebum, right? It's not only the glands, the sebaceous glands that are affected, but it's all epidermal cells. And so, look, there's not a great treatment here, right? Antibiotics keep the skin healthier and free of bacteria. Orthotricycline can work really well, but the problem is it has all of these other effects that estrogen has on the body. And isotretinoin has other negative effects on the skin. So acne is a tough one, right? Acne is a challenge. One of the major effects that the skin has is to control body temperature, right? And that's what we're going to talk about next. how does the body help control, or excuse me, how does the skin help control temperature? And so remember this homeostatic loop, right, where changes in temperature are detected, brought to the brain, specifically the hypothalamus, and then that causes some change, right? Because the brain signals to some effector something needs to change. So first off, before we even get into this, where does body heat come from? Body heat is created by metabolic reactions. Right? So that word is reactions, believe it or not. Your body, as it makes ATP from both carbohydrate and non-carbohydrate sources, doesn't do that with perfect efficiency. Instead, some of the energy that's in the foods that you take in, some of that energy doesn't get converted to ATP, some of it is converted to heat. Okay? And the greater metabolic demand you place on your body, that is if you're working out or if your cells are trying to fight infection, right? Metabolism demand and goes up, more heat is created, right? This warm blood through metabolism reaches the hypothalamus. We said that the hypothalamus is kind of the master regulator when it comes to maintenance of homeostasis, okay? And the effectors in this case are multiple. Surface blood vessels they open up. They dilate. Why? Because this allows heat to reach the surface. Deeper blood vessels, they constrict. Again, the question is why? Because when those blood vessels constrict, it changes the pathway of blood, right? The only path that the blood could now take is to get to the surface and to give off some of that heat, okay? The heat is lost in a process called radiation. A familiar term, but maybe not one you could define, right? What is radiation? This is where infrared rays, infrared heat rays escape from warmer surfaces to cooler surroundings. Okay, so I don't know if you've ever seen like the Predator movie, right? But if you've seen these films like this, or even how like a mosquito senses heat, right? What they detect is infrared radiation. That's heat that's being given off below the level of what you can see on the electromagnetic spectrum, right? So visible light has a certain wavelength, and X-rays have a certain wavelength. An infrared light has a certain wavelength. And so you can't detect it, it's below what your eye can see. But as you give off this infrared radiation, as you give off infrared rays, right, that's heat. That is heat energy. Okay? And so the most common way that your body loses heat, gives off heat, is by giving off this infrared radiation, right? And that is, for our purposes, synonymous with heat. But it's not the only way that your body is able to regulate heat retention or heat loss. There are 3 other different mechanisms. Let's talk about those next. How else does your body keep cool? Again, we're talking about cool right now, right? Trying to give off heat, because there's always a metabolic production of heat as your cells are making energy, right? So generally, right, we're going to be talking about how to give off heat. We'll come back and talk about what happens in a cold environment in a minute, but we're going to focus on how we cool down. We talked about radiation. A second way, right, an additional way that heat is lost is due to conduction. I think conduction is relatively easy to understand. This is where heat is lost to surfaces that make physical contact. So you place your forearms on the desk, right? And when you pull them off, the surface of the desk is warmer, right? That's a conductive heat loss. You've transferred that heat from your body to whatever might be in a physical contact with it, right? When you lay on a pillow at night and you flip it over because the other side is cooler, well, pretty soon the other side gets warmer, right? Why? Because of conductive heat loss. All right, what else besides conduction? Convection. Convection is when heat is lost to the air, to molecules in the air. And you have to imagine that air is in a continuous loop. It's swirling all around you. Right? The air is moving. It's never fully static. Okay? And so imagine this as like a cool breeze. Why does a cool breeze cool you down? Because you're giving off heat to the air. The air is cooler than the surface of your skin, and some of it's transferred, right? You're warming the air. But again, because the air is in constant motion, soon the air that you've warmed is replaced by cooler air. Right? Say there's that breeze and it pushes off the warm air that you've just warmed. Cooler air is left behind, and through convection, you warm that air as well, right? And so this is a continuous process. Now, when there's more convective current, right, that is, there's more flow of cooler air over your skin, you might cool down faster. This is why a breeze feels cooler than being stationary. The air is moving in either case, but it's moving faster when there's a breeze. Finally, evaporation helps cool us down. Evaporation. That's poorly written. The idea behind evaporation is that when you evaporate sweat, so sweat on the surface absorbs the heat and changes phase from liquid to a gas. And in doing so, sweating itself doesn't cool you down, right? What cools you down is when that sweat evaporates because it absorbs heat energy, right? So by being able to absorb the heat, and when it absorbs enough heat, it jumps phase. It's no longer liquid, it's water vapor, and what's left behind is a cooler surface. Right? And that's what's trying to be shown in this diagram here, right? So you sweat and there's some secretion on the surface of the skin. As this absorbs the heat from the skin, water molecules are given off and it leaves behind a cooler surface, okay? So the four ways that your body tries to cool itself down: primarily radiation, that's happening all the time. Conduction, it's happening right now too, even in the clothes that you're wearing. Convection, also happening currently, though if you're inside and the air's not moving around a lot, probably not so much. And evaporation, always just a tiny amount, but this really goes into overdrive when metabolic activity increases and you start to sweat.